In this lesson, you'll learn about reflections in the Graphs application. Start a new document and insert a Graphs application. There are a few changes we need to make to the graph settings. Press Menu and select Settings. Tab down to Grid. Press the right arrow and then arrow down and select Dot Grid. Now tab down and select Automatically Label Points. Then press Enter. I want to use the y-axis as a mirror and reflect points and equations. Press Menu, select Geometry, followed by Transformation, and then Reflection. Move the mouse over the grid so the tooltip displays Point On. Click on the grid to place the point. Now move the pointer over the y-axis. Notice that it becomes bold. Click on the y-axis, and now we have a reflection of point A, labelled A primed. Now we want the coordinates of these points. Move the mouse over point A, then press Ctrl followed by Menu. Select Coordinates and Equation. Do the same for A primed. We can't grab the reflected point, but we can grab and move the original point. So move the mouse over point A, then press and hold the mouse pad until the hand grips the point. Release the mouse pad and then swipe your finger across it to move point A around the screen. What do you notice about the relationship between the coordinates of the original point and its reflection? Now let's graph a parabola. Enter the equation for f1 of x as x squared. Move the mouse over the turning point. When the mouse changes to a set of crosshairs, click and hold the mouse pad. Now swipe your fingers across the mouse pad to move the graph. Place the vertex or turning point of the parabola in the third quadrant, down in the bottom left there. Let's see what happens if we reflect a point on the parabola in the y-axis. From the menu, select Geometry, followed by Transformation, and select Reflection. Point to the function and click. Point B is now on the function. Navigate across to the y-axis and click. Then press Escape to release the reflection tool. Grab point B and move it along the parabola. Notice that the reflected point, B primed, also moves in a parabolic path. We can use the information we learnt about reflecting point A. That is, reflecting a point in the y-axis makes the abscissa or x-coordinate the negative of its current value. Press Tab to navigate to the graph entry line and graph f1 of negative x. We have reflected all the points on our original graph in the y-axis. Now we have two more types of reflections to explore. So we don't get them all confused, let's delete all the reflections in the y-axis first. Hover over each item to be deleted, press Ctrl followed by Menu, and select Delete. Now, we will create a reflection in the x-axis using the same technique as before. notice that it is now the ordinate or y-coordinate that is a negative of its original value. So, to reflect the entire graph, we just make the y values negative. There are two ways I can express this. I'll use the relational graphing tool and write negative y equals f1 of x. Now we've reflected the graph in the x-axis. Now for the challenge, our final reflection. A reflection in the line y equals x. Let's delete all the reflections in the x-axis. A mirror can be a line, but not an equation. So I need to draw a line representing y equals x. Press Menu, select Geometry, Points and Lines, and finally Line. This is where our grid will come in handy. We need 2 points to define our line. I'll place the first point in the first quadrant, where x and y would have the same value, and the second point in the third quadrant, again where x and y would have the same value. Now we can proceed as we did before to create a reflection of a point and then an equation in the line y equals x. It appears that a reflection in the line y equals x reverses the coordinates. It swapped the x and y values. To create the graph, again I'll use the relational graphing tool. Our original function could have been written as y equals f1 of x, so I'll just swap the x and y around and write x equals f1 of y. Let's grab the original graph. Notice how the reflected graph moves accordingly. If you want an additional challenge, see if you can reflect a function in the line y equals 3 or x equals 2.